What's up, everybody? It's Mr. Gustin here in the chemistry classroom. I wanted to give you a couple of examples. One primary example of doing some mass to mass stoichiometry. So I'm going to work on example number 1 of our stoichiometry practice that you can find on Canvas, and you can follow along, and I'm going to kind of work through it with you. We did it in class, but I want to make sure you have an opportunity to kind of replay this over and over again, so here's the video for that. So example 1 says I'm burning gasoline. I'm going to call it octane this time. So gasoline is octane, pure octane. It releases CO2 into the air and obviously water vapor. You know that any combustion reaction with the hydrocarbon is going to release carbon dioxide and water. It tells me my problem. 103 grams of gasoline, this is octane fuel, is burned. How many grams of CO2 is released? Well, first thing we have to do is balance our equation. We want to make sure we understand that it's not 1 mole of octane and 1 mole of oxygen produces 1 mole of CO2 and H2O. We need to balance the equation first. So that's what I'm going to do here. So I'm going to start by putting 8 carbons, or 8 carbon dioxides there to balance out my carbons. I've got 18 hydrogens here and a coefficient of 2 or a subscript of 2. So I'm going to throw a 9 right there. And then on the right side, I'm going to have 16 waters here and 9 waters there. It's going to make 25. That's not going to go in there evenly, so I'm going to end up having to double everything. So 25, 2, 16, 18. I think that's going to be my balanced equation right there. Let me double check it. Yep, that looks good to me. So this is our balanced equation. This is where our mole-to-mole ratio will come from when I'm doing stoichiometry. Now, if you remember our steps that we went over in class, we said that if we start with the mass of a given sample, and in this case, here is our given, the first step is to use the molar mass to find the moles of that given. Moles of given. The second step that we talked about in class was then to go from moles of given through the balanced equation to find the moles of the unknown. In the moles of the unknown in this case, our true unknown, is grams of carbon dioxide, which is our third step. After we identify how many moles of unknown are produced or consumed, whatever we're looking for, we use the molar mass, or we use the molar mass to find the mass of the unknown. These are our 3 steps that we will be doing. These are 3 different conversion factors. The first conversion factor, we said molar mass is found on the periodic table. We use that like we did in the past to find octane or molecular oxygen and whatnot. The second conversion factor is from the balanced equation. That's where we find our mole-to-mole ratio. And then lastly, the other molar mass calculations also from the periodic table. All 3 of those conversion factors should be easily accessible to us based on our understanding right now. Now, I hope you have these written down somewhere. They should be in your notes. I'm going to erase it while we work through this problem. And I'll erase it 1 step at a time, okay? So let's go ahead and try the first step. So let's go ahead and we will use, start with our mass given, which is 103 grams of octane, and we will convert it into the number of moles that we're given using the molar mass. So I'm going to erase this step right here and replace it with 103 grams of C8H18. Now, I need to use the molar mass. So first thing I'm going to do is calculate the molar mass. And there are 8 carbons, there are 18 hydrogens. So I'm going to need to multiply it by the molar mass. And the molar mass of this ends up being something like 114 grams per 1 mole. And I have to ask myself, if I want to convert from grams of octane into moles of octane, I need to figure out what ratio I want. Do I want grams to moles, or do I want moles to grams? We talked about in class that any ratio we're going to use in our lives, anytime we're converting something, we always want what we are converting to on top and what we are converting from on bottom. So in this case, I'm going to want grams of octane down here and moles on top because I'm converting into moles from grams. What's my ratio? Here it is, 114 grams in 1 mole. That ends up being 103 divided by 114. I get about 1 mole. It's like 9/10 of a mole. We'll call it 0.9 moles. There's our first step. First step done. Next step. Let's take the moles that we were given and convert it into the moles of unknown using the balanced equation. I'm going to erase this step now. So I can go ahead and take 0.9 moles of CaH18, and I'm going to need to, again, multiply by some conversion factor. Well, what is the conversion factor between octane and CO2? I know that there are 2 moles of CaH18 per 16 moles of CO2. It tells me in the balanced equation, 2 and 16. Well, I have to ask myself, what factor do I want? Do I want 2 moles of octane to 16 CO2? Or do I want 16 moles of CO2 to 2 moles of octane? Well, where am I going? I am trying to find moles of CO2. That must mean that I want my moles of CO2 on top. I'm going to want 16 moles of CO2 on top and 2 moles of CaH18 down here. Go ahead and do that. It looks like I'm going to actually multiply it by 8 when it's all said and done. I get about 7.2 moles. 7.2 moles of carbon dioxide. That's my next step. Now the third step I have here is to convert that mole, the mole of unknown, into its mass. The last thing I want to do in order to find the number of grams of CO2 is take the moles of carbon dioxide, use the molar mass to find the mass. So I have 7.2 moles of CO2. I'm going to need a conversion factor. That conversion factor is my molar mass. I'm just not sure how to use that conversion factor yet. I know I'm going to end up with grams of CO2. When I calculate out my molar mass of CO2, 12 plus 16 times 2, 44 grams per mole of CO2. I'm starting in moles. I'm going to grams. I want to make sure I put grams of CO2 on top of moles. 44 grams in 1 mole. 7.2 times 44 gives me what answer? I end up with 300, or approximately 318 grams of carbon dioxide. 3 steps. I start with my given mass. I convert it into moles of the given mass, of the given chemical. I use that number to convert from moles of that chemical into moles of the unknown using the balanced equation. Then I take the moles of the unknown and use its molar mass as my conversion factor to figure out how many grams that will produce in this chemical reaction. These are our steps broken out 1, 2, 3. Very, very stepwise. Let's do another example where instead of individual steps, I like chained them together in this long chain like you'll see most often in either a textbook or on answer keys. So let's try example 2 together now, okay? You go ahead, and I'm going to give you about 2 seconds, or about a minute, you balance that equation. All right, let's try it out. The first thing I'm going to do is I see that there are 3 oxygens here. This is tough. There are 3 oxygens here and 2 oxygens there. Those are tough numbers. So I'm going to kind of off the top of my head say, you know what, maybe I'll put a 3 here initially and a 2 here initially to balance out my oxygens. Once I do that, I see 6 oxygens here. Awesome. 6 oxygens there. Awesome. How many KCl's? Well, there's 2 Ks, there's 2 Cl. I'll just throw a 2 right there. There we go. Now it's balanced 2, 2, 3. Question is, how many grams of potassium chloride? How many grams? Grams of potassium chloride. That's my unknown. Are produced if 25 grams of potassium chloride. This is my given. All right, we know where to start. We start with our mass of given. Let's start with 25.0 grams of potassium chlorate. 8. It ends in 8. I know chlorate is a common polyatomic ion on the backside of my periodic table. Make sure you check that out if you're not sure what chlorate is. KClO3. All right, that's the first step. Massive given. Now, I want to convert that massive given over into moles. So to do that, I'm going to need the molar mass. And I know I'm going to convert to moles. So I want moles on top, and I want grams on bottom of that conversion factor. Go figure out what the mass of potassium chlorate is. I'm going to do it right here. Potassium has a mass of 39.1 grams per mole, plus chlorine, which is like 35.5 grams per mole, plus 3 oxygens. I end up with 122.6 roughly. So in 1 mole, 122.6 grams for KClO3. That's the molar mass. That's my first conversion factor. But instead of calculating that, I'm just going to tack on the next conversion factor right here. Okay? So now I've gone ahead, I've converted it into moles of my given. Let's convert it into moles of unknown. What's the moles of the unknown? Remind me, the unknown is potassium chloride. It tells me right there, that's my unknown. Okay, well, if I want moles of unknown out, I want moles of KCl right there. And what I'm putting into my conversion factor is moles of given, which is KClO3. What is my ratio? Let's use the balance equation. It looks like for every 2 moles of KCl, I need 2 moles of KClO3. This step is going to be 1. Do I have to include it? Kind of, because it kind of lets you see that the ratio is a 1-to-1 ratio. It clearly indicates you're converting from moles of given to moles of unknown. Lastly, the last step we have here is to convert our moles of unknown into the mass of the unknown. The unknown is potassium chloride. I'm going to need potassium chloride's molar mass, and I want to find what the total mass of potassium chloride is, which means the grams will go on top, the moles will go on bottom. Let's calculate the molar mass of KCl. Again, potassium has a mass of 39.1, chlorine is 35.5. I get 74.6 grams per mole. Now, instead of having 3 steps, I've got one long factor here, which essentially says 25 divided by 122.6 times 1 times 74.6 is my answer. You do your math however you want to do your math. I'll do mine my way by putting it all in one step. And just like that, if I typed it in right, folks, goodness gracious, I end up with 15.2 grams, 15.2 grams of KCl as a result of the reaction with 25 grams of potassium chlorate. You now have 2 examples ready for you. Hopefully that simplifies things either into the stepwise form or into the long chain form. Either way, you should have a pretty good idea about how to attack mass-to-mass stoichiometry problems. All right? That's all I got for you. See ya!